Hello and welcome to Otten Math. In this edition of Otten Math, we're going to handle some problems involving solving quadratic functions by factoring. Okay, in this case we have factoring when the absolute value of a, so the value in front of the squared term, the x squared term, is going to be equal to 1. And what we're going to want to do, and there are different ways to do this. You can simply do this in your head, or you can recognize special product patterns, or you can use a diamond and box process. So that's what we're going to do in these three examples. So the first two things you want to do before you start working with the diamond and box process is first to see if there are any common factors. And we're going to start with number 1 first. And we see that there are no common factors in the coefficients for x squared or for x or for 1. So we move on to the next phase, and that is to figure out if there are any special product patterns. And in this case, there is a special product pattern. This is a perfect square trinomial, but we're going to use the diamond and box process anyway, just to go through the processes for these three. So what I'm going to do is I'm going to set up my diamond, this is my x, and I want the factors of c that add up to b. So the factors of 1 that add up to 2, and I know that 1 and 1 are the only two factors of 1. So I write in my left and right hand side of the diamond 1 and 1. I create my box. In the upper left hand corner, I'm going to put the first term, or the x squared value. In the bottom right, I'm going to put the 1. And then I'm going to put the factors 1x, or we could just say x, 1x. And then I'm going to fill out the top and left-hand side of the box with placeholders. So I find the common factors in the first column, it's x. Common factor in the second column, it's 1. Common factor in the first row, it's going to be x. Common factor in the second row is going to be 1. So I end up with a factored quadratic x plus 1 times x plus 1. Now if I wanted to solve this quadratic, it would have to be set equal to something. In this case, we'll say it's equal to 0. And by solving or finding the roots or the zeros of the function, I find out that x is equal to -1. Because -1 is the value that, when put in place for x, will make this equation true. And this is just a representative typically of what we want the y value to be. And when y is 0, then we know that the graph crosses the x-axis. So y is 0 along the x-axis. And so we can figure out that the parabola touches the x-axis at -1. Okay, we're going to go on to our next problem. So let's just erase all of this. And we're going to fill out our diamond and box again. We'll keep the box there, and then we'll just do some erasing in the diamond and with the factoring. Okay, so now we have y is equal to x squared plus 7x minus 8. So in this case, we're going to put the c value, or actually it ends up being a times c, but since the a value is just 1, it ends up being -8. So the factors of -8 that add to +7. So we're on number 2. So I list the factors of -8 that add to 7, and I can say that 8 and -1 are two factors of -8, or factors of -8 that add to 7. So I write an 8 here, -1 here in my box, my first term x squared, my c value in the bottom right corner, and then I have my factors 8x and just -x here. I put in my placeholders. Common factors in the first column are going to be x. In the second column, -1. In the first row, I have x again. And in the second row, I have 8. So again, I factor to x minus 1 times x plus 8. If I want to solve for x, find the roots of the zeros, x is equal to 1 or -8. Okay, moving on to our last problem. Let's take care of erasing this. Last problem gives us y is equal to x squared plus 7x plus 10. So again, we want the factors of the a times c value, which is going to be 10, that add to 7. And if I list the factors 1 and 10, 2 and 5, I see that 2 and 5 are the factors of 10 that add to 7. I place my factors on the left and right hand side. My first term for number 3 is going to be x squared. My c value is 10. I have 2x here, one of my factors, 5x here. Common factor, greatest common factor in the first column is going to be x. Greatest common factor in the second column is 5. Greatest common factor in the first row is x. Greatest common factor in the second row is 2. And again, I factored x plus 5 times x plus 2. Again, if I want to find the roots or solve for x or find the zeros, x is equal to, we set this equal to 0, x is equal to -5 or -2. Okay, moving on to the next problem, we have a word problem. The word problem is about a hopscotch pad that is 8 feet longer than it is wide. The total area of the pad is 48 square feet. What are the dimensions of the hopscotch pad? Okay, so let's create this hopscotch pad. We know that it's going to be a rectangle in shape. And we know that the area of the rectangle is equal to the length times the width. We know that the width is, we're going to call that x, and we know that the length is going to be 8 feet longer than the width. And we know that the total area is 48 square feet. So I know if the area is length times width, I know that that's x times x plus 8. I know that is equal to 48. I can rewrite that as x squared plus 8x. I subtract 48 from both sides is equal to 0. Now I set up my diamond in box because I'm going to factor this and solve the equation. Now I want the factors of -48 that add to plus 8. And I have 1 and 48, 2, 24, that doesn't work, 3, 16, 4 and 12. I think that's going to work, 4 and 12. So we're going to have -4 and 12, that adds to 8. I create my box here. And I place the first term in the upper left corner. That's going to be x squared. I have -48 as my c value. Factors -4x and plus 8x. And I use I find the greatest common factor in the first column. That's just going to be x. Greatest common factor in the second column is going to be plus 8. Greatest common factor in the first row is going to be x. Oh, it looks like I made a mistake. I copied this value over incorrectly. So we'll go back to change it. And when you're rushing through these things, sometimes you make careless mistakes like this. So, okay, so greatest common factor in the first column is x. Greatest common factor in the second column is going to be plus 12. Greatest common factor in the first row is x. Greatest common factor in the second row is -4. So we end up with x plus 12 times x minus 4 is equal to 0. I can see that -12 and 4 are my zeros. Well, I know that -12 cannot be a length for a side. So if I plug in -12 for x, that's not going to work out. So I can have a negative value for a length. So in this case, x is going to be equal to 4. That's going to be my width, and my length will be 12. So the dimensions of the hopscotch pad are going to be 4 by 12. And typically when you represent or abbreviate by, you use an x as well. So sometimes that can be misconstrued as 4 times 12, but in this case it's meant to be 4 by 12.